Hi, my name is Shane Glass, and I'm the Program Manager for Google Cloud's Public Dataset program. And I'm here today to talk to you about the public datasets we have available in BigQuery and Google Cloud Storage, as well as how they can support your workloads. And don't worry, there's a fun demo at the end too. Now, the mission of our public dataset program is quite simply to maximize the availability and accessibility of high-value, high-demand public data assets through Google Cloud. And we do this because we fundamentally believe that it makes life a little bit easier for our users. We currently have more than 130 datasets in our public dataset program, and these datasets are onboarded and maintained by Googlers with provider input and guidance. You can see here a sample of our data providers, including NOAA, the U.S. Census Bureau, the United Nations Statistics Division, the Federal Elections Commission, and others. We're constantly adding new datasets, and here are just 3 examples of recently added unstructured datasets, all coming from NOAA, the National Oceanic and Atmospheric Administration. They include a high-resolution rapid refresh weather model, the new GOES-16 satellite imagery, and NOAA's National Water Model that provides stream flow information across the continental United States. We also have datasets in BigQuery, including the GitHub repository, the NOAA Global Surface Summary of the Day that provides meteorological observations going back to 1900, and the Ethereum blockchain, along with 6 other cryptocurrencies. But don't just take my word for it. Let's see a demo, specifically looking at how you can use some of our geospatial datasets to support your workflows. So let's look at a demonstration that tells you how many lightning strikes there were across the continental United States in 2018, thanks to the lightning data we have available from NOAA. You can see here a query that runs real quickly, and it'll give you a concatenation in a little bit cleaner format so that it's easier to visualize this data in Data Studio. So we'll click Run down here, and a little like they do in the cooking shows, I already have it finished. You can see here the number of lightning strikes with a center point of a 1/10 degree by 1/10 degree tile that aggregates the strikes across the US. We'll take a look in Data Studio and see what we notice trend-wise. We'll flip over to our cooking show finished version, and you can see here the aggregated number of lightning strikes across a year on average. But this doesn't really tell us much, as it's hard to see the specific data points. So let's zoom in using the zoom area function in Data Studio. And we'll zoom in to the United States, and this is primarily where the data comes from. Now, I had originally expected Florida to have the most lightning strikes per day, but as you can see, what really stands out on this map is the collection of data here in Oklahoma. Now, I'm curious, and I want to dig in further, and how can you use public datasets to do that? Now, we can use the geospatial capabilities, or GIS, that are built into BigQuery, and this helps BigQuery understand the geospatial relationship between datasets. Now, this particular query has a little pre-processing done under the hood, but we're hopeful to make that unnecessary here in the near future. For now, we'll take the shortcut. And so this query gives us the return of a polygon for each tile, as well as the number of lightning strikes by day. But let's say we wanted to look at that in a more visual format. Well, I'd come over to BigQuery GeoViz, the geovisualization capability available for free. I could come down here and run the same query, see my results, and define which column is our geometry. And from there, I give it a style that best fits our data. In this case, I've given an interval for the number of strikes and the location. And I can tell you, as a former Oklahoma resident, this makes a lot of sense to me. The areas of Oklahoma that are notorious for the storms are also seeing the greatest number of lightning strikes. But this is pretty broad. These are 1/10 of a degree by 1/10 of a degree tiles across the state. Well, what does that actually mean? No one measures the world in 10th of a degree tiles. Instead, we define the world by boundaries. In most cases in the US, political and statistical boundaries, such as either counties or census tracts. In this case, let's take a look at one of the 10 boundary datasets we have available in BigQuery through the public dataset program that defines the space around each of these borders. In this case, we'll start with counties, since that's a pretty popular one in Oklahoma. We'll run a pretty similar query, except this time we'll take a little shortcut so that I only have to remember the state name as opposed to the state FIPS code. And again, we'll run our results and we'll see the counties. This time is the geometric column. And again, we can run our visualization and add style that meets the needs of our data set. And one of the nice features about BigQuery GeoViz is it allows me to go in and click on an individual county and see what the exact outputs were. And we can see here, for example, that Oklahoma County has about 300 lightning strikes per day. And this pretty closely lines up with what we saw from the other map, except on a more understandable boundary. What if we wanted to look at something more granular though? Say, for instance, zip codes. Again, we'll take the same data set, but this time we'll define it by the spaces of zip codes, or zip code tabulation areas in this case, and we'll run that through, and that gives you a better idea of maybe what zip code you want to avoid, assuming you don't like lightning strikes. We'll go through the same process, and we'll define the same style. This time, let's use a different method of defining that data-driven column. So let's use a linear extrapolation. We'll give it a low of 27, as you can see the minimum down here, and then we'll go up by 100 from here. So 120, 220, 320, and so on, and I'll want to get over my max of 499. I'll quickly set the colors down here, and I can scroll through some different options to find one that suits my palette. In this case, I want to use something pretty similar to the one I used in the counties. And you can see here, again, there's a dark concentration here around Oklahoma City. But this time, I can drill down to a more granular level and see which zip codes might make it the most likely for me to see some lightning strikes in my backyard. So this is just one example of what can be done with public data sets. If you're interested in learning more and figuring out how you can join public data sets with your private data sets, I encourage you to check out GCP Marketplace and click on Datasets on the left-hand side. There, you can learn more about datasets and get started in BigQuery today.